Okay, so here we go. Things are going to ramp up pretty quickly here. My only advice would be that I have a couple pieces of advice. One would be that you get your hands dirty, meaning you got to try this stuff, otherwise you won't learn it. And number two, you need to stay on top of it, meaning if you get overwhelmed, you need to come and ask questions. It will not go away. This chapter in particular is a building process. So the stuff that we do today, we're going to use on Monday. And then all of that stuff is going to be used on Wednesday and continues to build on top of it. It's not like we're going to do this and it just goes away. Okay. The other thing I want to remind you about is that some of you, I have a lot of definitions for you today. And some of you are just blindly writing down everything I say. If what I'm putting on this slideshow doesn't make any sense to you, then you're just wasting your time. So I would suggest you try to paraphrase as much as possible as we move through these definitions. Okay? 3 ways that lines can interact, I should say. They intersect, we've talked about that already. In other words, they have a point in common. They are parallel to each other, which is what we're going to spend a lot of time with in this chapter. Or the third case, which doesn't show up very often, but it's something called skew lines. If you're on a flat surface, also known as a plane, only 1 and 2 apply. You take 2 lines and you draw them on your paper. They're either going to intersect or they're going to be parallel. There's no other possibilities. However, the third case takes into account 3 dimensions. So it's easier for the people in the classroom to see it, but skew lines would be something like this. For those of you at home, you get something like this. Requires 3 dimensions. Since most of the work that we're going to be doing is 2-dimensional, number 3 won't be a very common situation for us. So realistically speaking, as far as note-taking goes, I would think that the only thing you wrote down on this slide would be what skew lines are. You already know what intersecting lines are. You already know what parallel lines are. Oh, by the way, I did not talk about the symbol for parallel there. It's 2 little lines right next to each other. That is a symbol for parallel. So we have parallel lines or we have perpendicular lines. There's no symbol for intersecting lines. And there's no symbol for skew. Okay, good. I'm just going to keep going, kids. If I start going too fast, if I lose you, just unmute and say something. If I don't hear anything, I'll assume everybody's with me. Okay, so there's a picture of 2 skew lines. Notice they're up off a plane. They have to be a 3-dimensional scenario. 1 and 2, 2-dimensional. Number 3, 3-dimensional. So I've got a picture like this. What I'd like you to do is, first of all, wrap your head around what you're looking at, and then we're going to answer some questions. Enya, which lines are parallel?
EG and KH.
Beautiful. I also wanted to do this so we can practice some naming stuff. So by EG and KH, I'm assuming you meant EG with a line over it and KH with a line over it, correct?
Yeah.
Beautiful. Well done. You'll notice smack dab in the middle of those 2 lines, I have an extra pair of arrowheads. That's how, in a diagram, we show that those lines are parallel. She didn't know that ahead of time, but I think it's pretty obvious for most of you that those are intended to be the parallel lines. Okay, good. Let's see. Charlotte, which lines are skew?
I think EG, maybe EG and KH.
No, those are the ones we just talked about. Those are parallel.
Okay, well, I'm trying to think like the lines that don't intersect, which would be parallel lines, but those don't work, right?
Correct, because they're parallel. So let's back up, Charlotte. Which lines intersect?
FJ and EG.
Perfect. Okay. So therefore, The third possibility has to be the ones that don't intersect and aren't parallel. It's a little hard to tell in this picture, but in this picture, it appears that these two lines intersect here. But that's not really happening because it's back behind the plane. It's a little hard to represent 3 dimensions in 2 dimensions, but our skew lines would be FJ and KH.
Okay, that makes sense.
Okay, beautiful. Okay, no other possibilities. All right, now we get into the fun stuff. We're going to take 2 parallel lines, sorry, not 2 parallel lines, just 2 lines, the black lines, and we're going to intersect them with a third line. That third line is called a transversal. When that happens, 8 angles are formed. And before we move on to anything else, let's just talk about these 4 angles up here. Forget about all this other business down there. We don't care right now. What's the relationship between angle 1 and angle 4, Danny?
They're across from each other.
Yes, very good. Which makes them what kind of angles and what's their relationship?
Vertical angles.
Vertical angles. And what's their relationship? What do you know about vertical angles? Emily?
They're not adjacent.
Good. What do you know about vertical angles?
They're like congruent to each other.
Correct. Okay, so again, let's forget about this stuff on the bottom. Suppose this is 15 degrees. How big is angle 4? Danny?
15.
Good. How big would angle 2 be?
Like adding up to 180.
So therefore, how big would angle 2 be?
165.
Good. And last but not least, how big would angle 3 be?
165.
Good. Okay, this has nothing to do with the transversal. That's just 2 lines intersecting. And we've done this already. So if we look at this small area here, those 4 angles, you're only going to have 2 choices. They're either going to be equal to each other or they're going to be supplementary. We're going to start through the lesson expanding that to incorporate all 8 angles. But for now, we just need to get some definitions under control. Okay, so what we're going to do is we're going to pick one angle from the top. That would be angles 1 through 4. And we're going to pick one angle from the bottom, 5 through 8. And that's going to form a new pair of angles. I believe we have 5 pairs to talk about. Okay. We don't care about angles 1 through 4. We did that already. So I'm not going to pick 1 and 4. Danny already told us about that. I'm not going to pick 1 and 2. We already did that. We're going to pick one angle from up here and match it with one angle from down here. Okay. And when we do that, we'll get an angle pair. And angle pairs are 2. So all of those other 5 angles we've talked about, vertical, linear pair, adjacent, complementary, and supplementary, always a pair of angles. Just 2, not 3, not 4, just 2. Okay, so here we go. If we pick 2 angles in the same location around the points of intersection, okay, now what do I mean by that? Here's one point of intersection. Here's the other point of intersection. This mooing cow is in the upper left-hand corner. Therefore, it's what's called the corresponding angle is also in the upper left-hand corner. Those would be called corresponding angles because they're in the same corresponding location around the points of intersection. There are 3 other pairs of corresponding angles in this picture. 2 is in the upper right, therefore it corresponds to 6, which is also in the upper right. 3 is in the lower left, therefore it corresponds to 7. And 4 is in the lower right, so it corresponds to 8 in the lower right, which is what that says. So it's one type of angle, but we have 4 pairs in that picture. Okay, let me stop for a second and make sure everybody's with me, because if you're not with me, it's going to get worse as we move on. Does everybody understand what we're doing? Yes or no? Good,
Yes.
good, 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 good,
Yeah.
good, good.
Yes.
Okay, we're good here. Everybody there good? If not, speak now. Okay. There we go. That's the first pair, corresponding angles. And again, you can remember that because it's in the same corresponding location. But again, there's not a lot of remembering here because you have access to your notes all the time. So, make sure you're taking good notes. Second pair. I picked an angle. The star's wearing the top hat. These 2 lines are being cut by a transversal. This part is called the interior because it's between the lines. And then obviously the counterpart to that would be all this stuff, which would be the exterior. Okay. Then we've got 2 sides of the transversal. They can either be on the same side or they can be on alternate sides of the transversal. So if you use a little logic, it would explain the name of these angles. Alternate, meaning they're on opposite sides of the transversal. Interior, meaning they're between the 2 lines that are being intersected. So the stars are the one pair. The other pair would be 4 and 5. Alternate again on opposite sides of the transversal. Interior on the inside. Only 2 pairs there. We're good? That's 2. Oh, notice the abbreviation 2. Remember we talked about this, or I talked about this, as mathematicians we're lazy, and we don't like to write out big words, so whenever we can, we abbreviate things. AIA, alternate interior angles. For corresponding, we had, there's no, I mean, I would probably say core angles. If you wanted to shorten it even more, so you don't have to write out the word angles. Okay, third pair. Alternate exterior. So again, if you break it down logically, alternate, opposite sides of the transversal, exterior on the outside. So the creepy unicorn is 1 pair. The other pair would be 2 and 7. And again, abbreviation here, AEA, alternate exterior angles. Alrighty then. What we haven't done is picked angles on the same side of the transversal. Okay, we've done alternate interior, alternate exterior, so let's pick some angles on the same side, which would give us what's called consecutive interior angles. However, I'll give you another name. I also like same side interior angles. Whoops. I don't care which one you want to use. Most people would prefer same side interior angles. Whoops, I spelled it wrong. Angles, there we go. Because it's a more logical description of what we're talking about here. Same side of the transversal in the interior, Therefore, 4 and 6 would be the other pair. Okay, tough question. Which one haven't we talked about yet? What would it be called?
Consecutive exterior angles.
Well done. Who was that?
Emily.
Good job, Emily. There they are. If you prefer, same side exterior angles, SSEA. And again, I don't care which ones you want to use. The walking alligators is 1, and therefore 2 and 8 would be the other same side exterior angles. Okay. Everybody good so far? Good. Good at home?
Like if you had if we had like a quiz or test and it
Well, you will have a
asked,
quiz or a test.
like,
You'll have a
which
quiz,
type
not a
of
test.
angles
But,
there are.
I'm sorry. What'd you say?
So like if we had like a quiz or test and it asked like what type of angles like these are, can we use like the abbreviation? Can we say it's like
Sure.
CEA or something like that, or do we have to write it out?
No, I would. I'd use the abbreviation as much as possible. That's why I gave you the abbreviation. Now, the one, what we haven't dealt with, and we're not going to deal with directly, is what about an angle like angle 4 and this alligator? Now, they are alternate angles because they're on opposite sides of the transversal, but one is in the interior and one is in the exterior. So this is not a pair that we deal with. Just the 5 that we've already talked about. Corresponding, alternate interior angles, alternate exterior angles, same side exterior and same side interior. And you'll also notice that these are just definitions. We didn't talk at all about the relationship between these angles. Just the fact that they are these types of angles. In a couple minutes, we're going to talk about the relationship between each of these pairs. Okay. Similar picture. I just changed the numbers into letters so that it's not just a matter of puking up the numbers or memorizing the numbers. So question number 1 is, name a pair of corresponding angles. Alex, let's start with you.
Corresponding angles.
Yes, sir.
Would it be E and S?
E and S are not corresponding angles. Want to try again?
E and U.
Say again?
E and U.
E and U are not corresponding angles. Third time's a charm.
E and M.
E and M are corresponding angles. Good. Upper left, upper left. Give me the other 3 pairs, please.
J and U. Or
Nope.
no, my bad. J and O.
J or OJ.
Yeah.
Yeah.
A, U, and W, S.
Well done. Can all of you hear him at home? ME is one pair. OJ is another pair. UA is another pair. And SW is another pair. 4 pairs of corresponding angles. Lorenzo, which ones are alternate interior angles?
E and U,
Good. And the other pair?
X and J,
Well done. How about some alternate exterior angles, Nia?
M and A.
Good. And the other pair?
O and W.
Good. Ma and ow. How about some consecutive interior, also known as same side interior? Katie.
S and E,
Good. And the other one?
U and J.
Perfect. Last but not least, the consecutive exterior, also known as same side exterior. Megan.
M and W and O and A.
Perfect. Okay, good. So we can identify those pairs, 5 pairs of angles. Okay, and we went from the terms to the angles. You should also be able to go from the angles to the terms. So I know sometimes you're like goldfish and you have a short attention span, so I'll try this. If I pick S and J, what kind of angles are S and J? Even though we just talked about this, again, you should be able to go from angles to the types of angles. Yes, sir.
Alternate interior angle.
Very good. Alternate interior angles. Okay, so it's a two-way street. You got to be able to do both. Now, we're going to make things a little bit more interesting. You'll notice that this picture is a little bit different, and this will be a precursor into where we're going to go, what rabbit hole we're going down now. So you'll notice that this picture is different from this picture. Lily, what's different between that picture and that picture?
There's a number in where J is.
Okay, good. We have an actual angle measure. Good. What else you got for me? I'll just keep flipping back and forth so you can see.
There's a pair of parallel lines.
Beautiful. These are parallel. These are not. Anything else for me, Lily?
Can you go back?
Sure. It's okay to say no.
In example 2,
Yeah.
there's a letter T
Yep.
above the line that intersects.
Yep. Good. And there's a lot of other smaller things. Like in this picture, I didn't make the transversal red, whereas in this one I made it red. In this one, I named the letters, or the angles with letters, which is weird. We don't normally do that. This one I have numbers. Okay, so here we go. Bobby, you're up. There are 7 angles in here that I didn't give you measurements for. What I would like... I just lost all of Zoom. Are you guys still there?
Yeah.
Oh, that's weird.
Yeah.
Okay, good. I can't see you anymore. Something strange just happened. Oh, you're back. Hi, everybody. Okay, let's try that again. Bobby, back to you. I've got 7 angles that I don't know the measure of. Can you give me as many angle measures as possible, please? Any order you want, just go.
That we don't know the measure of.
Well, you got the 65 to start. So that's the one angle I'm going to give you. That angle is 65 degrees. Can you tell me the measure of any other angles in that picture?
No.
Yes, you can. You're a smart feller, I mean.
For 6, it's 65 as well.
Good. Okay. Wait. Hold on. Wait. Whoa. Slow your roll, Holmes. The big important question that many of you are going to hate is, why is that 65 degrees? Bobby.
Well, because for 5 and 65 degrees, there will be a supplementary angle, so it'd be 180 degrees. So you can guess the 6 and 7 are also supplementary angles and are equal 180 degrees.
So therefore, how big are 5 and 7?
5 would be 115, and 7 would also be 115.
Okay. I'm assuming everybody's with us here. What's going to happen as we progress through this problem is we're going to get a whole bunch of different values a whole bunch of different explanations as to why these angles. So he said that angle 6 was 65 because 5 would be supplementary, but 6 is also supplementary to 5. So if this is 115, then 6 must also be 65 because these two have to be supplementary. Perfect explanation. However, also notice that 5 and the 65-degree angle are vertical angles. That would make that 65. Okay, well, why is the angle 7 115? It's a vertical angle to angle 5. It's supplementary to the 65-degree angle, and it's supplementary to the number 6 angle. And there's nothing new there. That's what we did at the very beginning of the slideshow. What's going to get crazy now is how do we find the measures of 1, 2, 3, and 4? Mia, any ideas?
Use the values from the pairs in the bottom because they're gonna end up being congruent because they're parallel.
Ooh. Okay. So therefore, how big would angle 1 be?
115 degrees.
And 2?
65.
Keep going.
65 and 115.
Beautiful. Now, do you have any basis for that, or are you just guessing that since those lines are parallel, those angles would be the same?
I'm basing it off of how they're parallel.
Okay. To make your life simple, please notice that there are only 2 angle measures in that entire diagram. And also notice that this only works if the lines are parallel. So that's going to lead us into a bunch of new theorems/definitions. Okay? And they go the following. Everything that Bobby and Mia told us was 100% correct. Before we talk about this current slide, I need to talk about some geometry operations. What they did is all true, but we want to be able to prove it. Okay, so when I said to Bobby, why was angle 6 65 degrees, he gave me an answer involving supplementary angles. I also suggest an answer involving vertical angles. That's what we would constitute as an explanation or a proof of why that is true. However, when Mia gave us the angle measures up on top, it was kind of based on a gut feeling, an idea, a visual cue, but it's not really a proof. We want to be able to prove it. And so in order to do that, we want to be able to prove that all of these relationships are the same, or are true, I should say. So we're going to start with somewhere. This is something called the corresponding angle postulate. Now, let's talk about the word postulate. We've already seen, and I don't think we've actually talked about it, but we've seen the word theorem. And a theorem is something that can be proven. That can be proved. Okay? So I have a theorem. If I drop this, it will fall. Can I prove that?
Yes.
Just did. Okay. Will that always happen? Anybody at home? Will that always happen?
In this setting, yes.
Yeah. Okay. Ignoring the fact that I could be in space, I could be in a wind tunnel, whatever. Okay. That's a theorem. A postulate is something that you believe to be true, but you can't necessarily prove. Okay. The best example that I have for a postulate is, and again, this is where this is the one time of the year I violate my 2 rules, and that is I never talk about religion or politics, but I'm going to talk about religion. The existence of God is a postulate. Okay. Many of you, and we don't need to get into a religious discussion here, but I will say that many of you believe in God. You have no proof of the existence of God, but you do believe wholeheartedly that God exists. That's fine. That's called a postulate. So we're going to start with this postulate. And this postulate says exactly what Mia just explained to us. If we have corresponding angles, and parallel lines, then the angles will be congruent to each other. So if we go back to this picture, okay, does it make sense? Well, yeah, here's my corresponding angles. 7 corresponds to 4. Those are congruent. The 65 corresponds to 2. Those are congruent, et cetera, et cetera, et cetera, all the way around the picture. Okay? But again, I'm not proving it. I'm just telling you that that's the case, and we're going to move on from there. Okay, questions before I move on, because this is kind of important. We're good? Make sense? Okay. Everything else, all the other relationships that we saw in that last picture or last slide can now be proved using this corresponding angle postulate. So we get this one. Alternate interior angles are congruent. And if we were in a different setting, I would have some methods for you to discover this on your own, but we have this little thing called COVID, so I can't do it. But it says that the alternate interior angles are congruent to each other. Well, how do we know that? Okay, let's go back to this slide, get rid of some of this stuff, and we'll start over. Okay, so the argument here, according to the theorem, the argument is that that should be 65 degrees. Well, how do we know that? The only thing we have to operate with is the corresponding angle postulate, which means because of this, I would know that that angle is 65 degrees, because angle 2 is the corresponding angle to the 65 degree angle that we're starting with. Then angle 2 and angle 3 are congruent because they are vertical angles. Done. Okay. And obviously then those are congruent, which also means that 4 and 5 are congruent because that's the other pair of alternate interior angles. And that's how that process goes for the next couple theorems. All right, let's go back to this. We talked about corresponding already. Whoops. Corresponding, check. We talked about alternate interior, check. Okay, so this was congruent. This is congruent. Let's do alternate exterior angles. What's the relationship between alternate exterior angles? Without actually showing you the theorem.
They're supplementary.
Good. Why, Emma? Or hold on, let's back up. Not why. Which 2 angles in this picture are alternate exterior angles? Emma.
2 and 6 and 1 and 7.
All right, let's work with 2 and 6. So you're presenting the idea that those angles are supplementary. Yes?
Yeah.
Okay. And refresh my memory, what does supplementary mean?
When added up, they equal 180 degrees.
Okay. So in this picture, how big is angle 2?
65 degrees.
Good. How big is angle 6?
65.
Okay. So are they supplementary?
Oh, no.
No. What are they?
They are congruent.
Good. Okay, there's our third theorem. The alternate exterior angles are congruent. Same side interior angles. Who haven't we heard from? Olivia. Let's start with this. Can you give me 2 same side interior angles in this picture, please?
3 and 5 and 4 and 65.
Good. We'll work with 3 and 5. What appears to be the relationship between angles 3 and 5?
They are congruent.
Okay. So let's work that out then. How big is angle 3?
115.
No. It's alternate in
65.
65. How big is angle 5?
Oh, that's 115.
That's 115. So what's the relationship between 3 and 5?
Supplementary.
Supplementary. And this is what I talked about the other day. For all of you, the thing that's going to help you in this is understanding and not memorization. So look at those angles there. We talked about it already. All the angles in that picture are either acute or obtuse, which means that all the acute angles have to be equal to each other. All the obtuse angles have to be equal to each other. And each acute angle is supplementary with a obtuse angle. Okay, we got one more to do. Same side exterior angles. Daniel, you're up. Give me a pair in this picture of same side exterior angles.
1 and 7.
Nope, those are alternate exterior angles because they're on opposite sides of the transversal. So again, break the name down. Same side exterior angles.
1 and 6.
Good. 1 and 6 are in fact same side exterior angles. Now the big question is, what's their relationship? Are they congruent or are they supplementary?
Supplementary.
They are supplementary. Very good. Angle 1 is obtuse. Actually, it appears to be obtuse. We'll assume it is. Angle 6 appears to be acute. Therefore, they can't be equal. If they can't be equal, they must be supplementary. Okay, good. So we took the definition of these angle pairs, then said, okay, let's look at a special case when the lines are parallel. And if the lines are parallel, we get all these relationships. And that's what I have on the next couple slides. So we did that one already. We did that one. We did that one. We did that one. We did that one. We're good to go. Okay. Oh, before I move on, any questions? Any of those you need to talk about more, or are you good to go for all 5 pairs? Okay, beautiful. Now, what if they're perpendicular? Who cares? If they're perpendicular, it's even easier. Notice in this picture, if you haven't noticed already, every one of these angles is 90 degrees. Done. Now, the weird thing about the 90-degree angles is not only are they congruent, but they're also supplementary. So you pick any 2 angles in that picture, and they're going to be congruent and supplementary at the same time. Okay. What we're going to do now, give me a second here. Let's take a 5-minute break because we're going to get into some algebra now. We're going to take what we learned about the angles and start setting up some algebraic equations. So before we do that, let's take a 5-minute break. Who do you have for a teacher?
Mr. Hamilton?
Okay, it's 12 o'clock. Let's rock. We're going to take the ideas that we used with angles already. And so notice within this lesson, even within the lesson itself, we're doing a building process. So we started by defining the pairs of angles that we're talking about. By the way, we're up to 10 pairs of angles now. This gets a little overwhelming. So make sure your notes are organized so that you can find this information quickly. Then we said, okay, well, we know what these angles are. We know what alternate interior, alternate exterior, corresponding consecutive interior, consecutive exterior. What happens when the lines are parallel? We did all that. Now we're going to start solving some algebraic problems. So here are some hints to solve algebraic problems. What type of pair of angles are you talking about? Which of the 5 that we discussed today are you dealing with in a picture? Number 2. You need to decide, are you going to set them equal or add them up and set them equal to 180? There's no other possibility. Don't do anything crazy. Just set them equal or add them up and set them equal to 180. And that would be, you would know the answer to part 2 based on what you got from part 1. So for instance, if you realize you have alternate interior angles, you would know that alternate interior angles are congruent, and therefore you would set them equal to each other. Step 3, solve for the intended variable or angle. Sometimes those are one and the same. X represents an angle, sometimes it doesn't represent an angle. And then step 4, plug your values back in to find angle measures. Okay, we good? No, hold on. Waiting. Again, I would encourage you to paraphrase this if you need to. Solve for the intended variable or angle. If that doesn't make any sense for you, paraphrase it into something that does. Solve the equation. Figure out what x is. Whatever's going to work for you so that when you look at it, it actually makes sense and you're not just blindly copying things down. Give me a thumbs up at home if you're good to go. All right. Everybody good? Okay, here we go. All right, so I'm gonna work through this one, and then we'll go from there. Okay. So notice I want to find x, and I want to find the measure of angle 4. So looking at my picture, I have this angle, and I have this angle. Step number 1, what pair of angles am I talking about there? Are those corresponding, alternate interior, alternate exterior, same side exterior, or same side interior? And notice I turned the picture a little bit to make things more interesting. So, what kind of pairs of angles are those?
Same side exterior.
Good, beautiful. Same side exterior. That's a good start. What's the relationship, Emily, between same side exterior? Are they congruent or supplementary? Bingo. Now, you could either look in your notes for that, or notice I've got an acute angle, I've got an obtuse angle. They have to be supplementary. So what equation would I set up? Perfect. Let's see. 2x is equal to, that's 140, 40. So x equals, according to my math, 20. All right, Emily, back to you since you started this mess. How am I going to find angle 4 now? Okay, so that would make 2 times 20 is 40 plus 15 is 55 degrees. And therefore?
Subtract that from 180.
Love it. 180 minus 55 is equal to? Bingo. Notice, oh, look, we have a 125 degree angle right there. Corresponding angles. Is this wrong? Absolutely not. It's perfect. Just a different way to attack the same problem. Stretching or question?
Question.
Go.
I was gonna say, can we just use cap corresponding angle for that finding 4?
Yep.
Saying, oh, those two are corresponding angles.
Yep, you could have done that right away. But again, two different ways to solve the same problem. Okay, questions at home? Okay, now you do this one. Leah, let's go to you. I know you haven't finished yet, but tell me what you've started.
So I started solving for x, and what I did was 9x plus 12 plus 3x is equal to 180, because how do I say it?
I don't know.
Like the vertical angle for 9x plus 12 is like on the same line as 3x. Like, I don't know if that makes sense.
It makes sense to me. I don't know if it makes sense to everybody else. Hold on. Before you continue to explain, notice that this angle and this angle are not any of the pairs we've talked about. Those aren't alternate interior, alternate exterior, corresponding, blah, 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 blah. So what Leah has noticed is that this angle and this angle are the same. So this would also be 9x plus 12. And these are, what kind of angles are those, Leah?
Supplementary.
Good. What pair of angles other than supplementary are those?
Adjacent.
Nope, those aren't adjacent. They don't share a vertex. What pair of angles from what we've talked about today?
They are same side interior.
Perfect. Solving this, we get 12x equals 168. So x is equal to, a little help please, 14? Is it 14 exactly?
Yeah.
Beautiful. Okay, now what, Leah?
I haven't gotten that far, but you would subtract 180 from, like, you would subtract 14 from 180,
Keep going.
and then you would set 4y minus 10 to that value.
Well, okay, you're on the right track, but we got to plug 14 in there.
Oh, yeah.
Yeah, so this angle would be 42. Let me change colors here. This angle would be 42 degrees, and therefore this angle would be 138. And as she said, set 138 equal to 4y minus 10 and solve. Okay. Good. There are other ways to solve the problem. There are a lot of other ways to solve the problem. For instance, let me get this mess out of the way. Another way to do it, which is probably not the method that most of you used, but I noticed that these two angles are supplementary. So I could do 3x plus 4y minus 10 equals 180. However, that's not solvable. I also realized that the 4y minus 10 and the 9x plus 12 are alternate exterior angles, which makes them equal. So 9x plus 12 would be equal to 4y minus 10. Oh, look, we've got a nice little system there. Again, not the method that most of you would use, but another possibility to solve the problem. Last thing today is what's called a crook problem. It's called a crook problem because this line has been bent into a crook. In order to solve this problem, I have to create scenarios based on what we did in the previous slide. So I'm going to draw what's called an auxiliary line in here. And I'm going to draw a line right through there. And I'm going to guarantee that all three of these lines are parallel. Now, it is possible to do a crook problem where you've got more than one crook, but for now we're going to start simple. The biggest thing to notice is that this angle 1 is split into two angles, this one and this one, but those angles are not bisected. They're not equal to each other. Okay, once you draw your auxiliary line, and the way to solve this problem is you work from the bottom up and you work from the top down. Okay, so what does that mean? Well, I know that if this is 144 degrees, this angle would be 36 degrees. Because the 144 and the 36 are same side interior angles. Working from the top down, if this is 62, this is also 62 because those two angles are alternate interior angles. And therefore, angle 1 would be 36 plus 62, which is 98 degrees. Again, drawing your auxiliary line, work from the bottom up and the top down. We good? We're done. So day 2 for homework. Again, I would say the biggest thing that will help you out is if you have your notes organized. This will make a lot more sense.